thermal fluid sciences experts. This is ProReadyEngineer.
Heating value. Now, you see, we went from temperature, that was very common, to pressure, less common, to heating value, that's even less common. You see, heating value is a very nice concept. It simply means the heat content. Think of it, the amount of energy in the thing that burns. To the most part, we use that for fuel. We talk about fuel heating value. See, fuels like hydrogen, like natural gas, like the gasoline in your car, like the diesel, like the jet A that sits in an engine, like the coal, like the whatsoever, these are all fuels. You see, we burn them. Why do we burn them? We burn them because we need the energy stored in them. If this cup is a cup of diesel, as it sits, there's no value. If I have diesel sitting here, that's doing nothing. Now, the value of this diesel is when it burns and releases the heat, whether it be because you are using it for heating purposes or for power, like generating work from a car engine burning diesel. What is a diesel engine? What is a gasoline engine? Your car, what does it do? Here's the car. You put fuel somewhere and you release the energy and you change it to the tires. You go from this to the tires spinning, right? Energy is converting itself from this to heat to work. So heat, the energy, when you burn this, what will get released is the LHV, is the heating value, right? By definition, take 1 kilogram of the matter, burn it, and we say it's X kilojoule per kilogram or megajoule per kilogram, right? Or if you are using British units or US units, you say BTU per pound, right? British thermal units per pound. Energy per unit mass. If I take this 1 unit mass and burn it, that's what I get. Very simple. Now, let's build a feel for it. Let's build a feel for that energy. How much is that typically? You see, if you use this number, if you say liquid fuels, meaning things like diesel, like jet A, like kerosene, like gasoline, see all these families, if you say give or take it's about 20,000 BTU per pound, you're not very off, you're doing reasonably well. 20,000 BTU per pound, or in SI units, 45 megajoule per kilogram. 45 megajoule per kilogram. Good enough. You see, when we express that heating value, the amount of energy in something, we either use it per kilogram of the thing or per unit volume of the thing, right? Now, why do you think we like per unit volume? This chart here. What is this chart doing? What am I trying to communicate to you? It's again the LHV, which is energy, but per volume. I think this should have came across to you. The reason we like volume is it relates to how we will store the fuel. Now think about that. Your car, you go, you fill it up, you say I've put in 17 gallons. That's volume. You put in it 17 gallons, like a gallon of milk, 17 of that fuel. We like to know, because we are going to build a volume. The tank, gas tank is a volume. We're going to put an amount of fuel, and you want enough energy. You want enough energy so you can drive for a couple days. So we like energy to be expressed in terms of volume because of transportation. It's going to take a volume. It's going to take a volume to put in it, right? And when you think in terms of that, you will see that, take a look here. on the gasoline, the diesel, the ethanol, and the biodiesel. Take a look at this family. What do you observe? Say very large. If you use 120,000 BTU per gallon, that's a reasonable number to remember. Now, take a look. Compare it down to here, to liquid hydrogen and natural gas. These numbers are tremendous. You know what does that mean? You can get tremendous amount of energy from a small amount of fuel. Now you know why aircraft engines fly with this liquid fuel, because it will carry a certain amount, but that certain amount has tremendous amount of energy. It doesn't, they have been speaking about using hydrogen for powering these aircrafts, and there are a couple challenges with that. One of them is, look at the heat content of that hydrogen versus the other liquid fuels that we typically use. That's one problem. The other problem is, where is the hydrogen? Where do we bring the hydrogen from? Just think about that. These fuels, these liquid fuels are under the ground. You just, drill, comes out, here you go. Now it's oil, you get refined, but it's there, it's sitting in the ground. So where is the hydrogen sitting? It sits nowhere, there's no hydrogen. We have to make it, as that's a different story. Okay, but anyways, so LHV knowledge is extremely important. It's how we say this fuel have this energy in it, and I can take that energy and make work. Drive my car means make work, because it's spinning. You've generated work, that's work when the wheels are spinning, right? I change that heat to work. Or I take that stored heat, I burn it just for, like when you sit in your home and you turn the heater on. If it's a natural gas heater, then you're burning natural gas to make the air warmer, right? You're taking this energy to heat the air. So we want that LHV for many things related to engines and boilers and furnaces, analysis, if you will. This is where you will see it. How is it measured? Well, two things come to mind. The gas chromatograph sort of looks like that, not necessarily what you will see in the field, but this is one example. And the other device is the Wobbe meter. These devices, they run in the field with gas turbines, and essentially the gas goes in, you measure, tells you, well, this gas I am burning right now has an LHV of 19,000, 18,000, 20,000, 21,000, right? BTU per pound. And the Wobbe meter does the same. And I'm not trying here to go into the details, why two, which is better, why do we do this? All this information is extremely important for people who work in combustion in gas turbines, but I'm not going to go over that here. I'm just scratching the surface for you to set you up for success, so you know what the value means, have a feel for it, and what measures it.